In this week's video, you're going to be learning the fundamentals of network automation, which is a completely new way of doing our day-to-day jobs as network engineers, where instead of going from one device to another and configuring them individually, we can do it through a program, like a Python program. Hi, my name is Kevin Wallace, and this video is a replay of a live event that we did back on Cyber Monday 2022, where we covered network automation. And it's a long one, so you might want to get comfortable for this one, get ready to take a lot of notes, and get ready to do some hands-on practice with network automation. And we'll begin by taking a look at a few of the network automation certifications out there, and I'll give you my recommendation. Then we'll give an overview of software-defined networking, or SDN, see what that's all about, talk about RESTconf and NetConf, how we can do data modeling for a network device, and then we'll do lots of demos. We'll get started with a utility called Postman, which is going to allow us to send commands to a network device using HTTP verbs, something we're going to refer to as RESTconf. We'll see how to do that using a Cisco CSR 1000V out at the Cisco DevNet Sandbox, and in the real world, after you know what you want to send via RESTconf, instead of doing it all through Postman, you probably want to do it through a program. So then we'll get into Python. You'll learn how to do some basic programming in Python, and we will write a program that will go out and make a configuration change on a CSR 1000V that I have running locally. And at the end of this video, which I think is about an hour and a half long, you're going to come away with a great introduction to network automation. And I've got some resources for you to download as well. I mentioned that this video is a replay of an event that I did on Cyber Monday 2022. And in that event, I let attendees download a zip file. And you can do the same thing. Just go to kwtrain.com/CM for Cyber Monday, CM22. And that zip file is going to contain the Python program that I write as part of the demo. And one of the network automation certifications we'll discuss is Cisco's DevNet Associate. Well, this download also gives you a complete Cisco DevNet Associate practice exam. It's a PDF that you can print out. It's got detailed explanations for the questions. And I've got another PDF ebook for you, and it's called 4 Ways to Get Hands-on Practice for Your Cisco Exam. And I also visit a few different sites in this video, and I'm giving you those links in the resource links section of this download. All right, I hope you're excited and ready to get started as I introduce you to network automation. As you're deciding what your next steps are, as you're planning your vision for next year, let's think about what certification or certifications you might consider in network automation. And here's the big challenge. Unlike cloud and unlike just basic networking, and unlike cybersecurity, there's not really a industry recognized vendor neutral network automation certification. They tend to be very vendor specific. So that's the challenge. If you happen to run a Juniper shop, for example, they have the DevOps Associate Cert, and they have the DevOps Specialist Cert. Again, that's for the Juniper environment, the number 2 networking vendor right now. But if you're joining me, you're probably more of a Cisco shop, maybe a mixture, but I would personally focus on Cisco network automation certifications. And I know on Friday I said, well, depending on where you are in networking, you might want to do this one. Here's another great certification you could take. And for cloud, oh yeah, you could take this one, or you can take this one, or maybe you take this one first. This one's super clear. Here's my recommendation. You ready for this? If you don't currently have the Cisco DevNet Associate, I think you should get the Cisco DevNet Associate sometime next year. I think that is a clear best next move for you in that one pillar of our IT career Parthenon. If you've already got your DevNet Associate, congratulations. You may want to look at DevNet Professional. Tremendous demand for that right now. And if development is your life, if you've got coding in your blood, there's even an expert level. You can get your Cisco Certified DevNet Expert certification. I'm personally never going to go for that one, but more power to you if that just resonates with you. It's like we were saying on Friday, if that's for you, you're going to know it. It's going to call to you. It's not calling to me. I'm going to be happy with the DevNet Associate and just be conversant in that world. So those are some certifications to think about. Again, the takeaway is if you don't have the DevNet Associate from Cisco, I think that's your move for next year. I think that's going to be my move for next year as well. Now, let's get into what network automation is all about. And I'm going to use a few terms synonymously. When I say network automation or software-defined networking or network programmability, I'm probably talking about the same thing. Kind of goes by some different names. But let's talk about SDN, software-defined networking, and what makes it so different than what we've had in the past. Traditionally, the networks that I grew up with, I guess we could say, were routers, switches, maybe firewalls. And to configure them, I would go in with my console cable, or I would telnet or secure shell into those devices, and I would one at a time configure those. And inside of each of those devices, there are 3 different planes of operation, if you want to put this in your notes. There is the data plane, and the data plane is concerned with getting packets for routers or frames of switches. It's concerned with getting data in one port and as quickly as possible sending it out the appropriate egress port. And up at the control plane, that's where we run algorithms. If we have a router, for example, and we're running the OSPF routing protocol, then we're going to be running the Dijkstra algorithm in that control plane. If we have a switch, we're going to be running spanning tree protocol in that control plane. And then finally, the management plane, that's how you and I as network administrators communicate with that device. Maybe we secure shell in. We're connecting via the management plane. And this is the way I've done networking for literally decades, like 3 decades. And the term given to this is a distributed control plane. But notice what I just introduced to the topology. I brought in an SDN, a software-defined network controller, and those control planes that used to reside in the devices, they went up and they now live in the SDN controller. So now it can be in charge of running all those algorithms and sending appropriate configuration instructions out. Now, please hear me on this. It's not always that way. It just depends on what equipment you're using, what your application is. Sometimes the control plane stays where it was. It stays in the router. It stays in the switch. So please don't chat in, oh no, Kevin, there's an exception. Yeah, there's lots of exceptions, but I'm just saying this is an option. You might see a situation where the control plane actually is residing in the SDN controller. If you do, that's called a centralized control plane. And Cisco, I love the term they use. They talk about intent-based networking. Instead of me going to a router and say, I want to configure this for quality of service, let's create a class map and a policy map and apply that with the service policy command. No, we just express our intent. We say, yeah, I'd like to prioritize video. I'd like to deprioritize Xbox traffic as an example. And that's the kind of thing that we can do, because when I set up quality of service on a switch or a router, it's different commands, totally different command set, but I've got the same intent. I still want to prioritize the same traffic, but it's different commands. I don't have to worry about the individual commands. I express my intent to the controller, and it sends appropriate instructions down to the routers and switches, and not just Cisco routers and switches. Anybody that wants to conform to this Yang data model that we're going to be talking about later, we can configure Juniper and HP, and the list just goes on and on. Whatever vendor supports it, we can configure their routers even if we don't even know the syntax used on those routers by expressing our intent. Now, the question is, what kind of commands are we sending from that controller down to those devices that we're configuring? And it's we oftentimes call those southbound interfaces. What they really are APIs. You might have heard that term a lot. An API, that's an application programming interface. That's the way that one piece of software talks to another piece of software. And when we draw this out, we typically draw the devices that we're configuring below the controller. In other words, south of the controller, if you think of a compass. So we call those southbound application programming interfaces, or southbound APIs, or for short, just SBIs, for southbound interfaces. Those interfaces are ways that we're programmatically sending configuration information down to the devices to be configured. Some examples could be traditional things. I mean, we've been using simple network management protocols long as I can remember. I used it back in the 1990s. Secure Shell, heaven forbid Telnet, let's not use that one, but that is one. We're today probably going to be using something like netconf or restconf. We're actually going to set up restconf today. You're going to see it in action, and it is impressive. Cannot wait to show you that. But that's the language of love, if you will, or the languages of love that's going to be spoken between the controller and the devices to be configured. But I said we're going to do intent-based networking. We're going to express our intent, what we want to configure. We're going to express that intent to a controller. How are we going to do that? Well, we're going to do that through an application. Now, please hear me on this. That application might be something we write, kind of like we're going to do today, or it could be built in. Oh, didn't mean to hit the back arrow there. It could be actually built in to the SDN controller itself. You see, the controller that Cisco often uses is called Cisco DNA Center. And Cisco DNA Center, if you go to its web interface, it's going to... In fact, I was trying to remember. I think I might have given you a link to that in Friday's show notes. But DNA Center, you can go to the web interface, and it's got a lot of applications built in right there. So this application, even though I'm showing it as being separate, I'm showing it being above or north of the controller. Yeah, it could be part of the controller. But somehow we're going to use some application, whether it's on the controller, whether it's a Python program that we write, we're going to send instructions down to that SDN controller. And because the applications are typically thought of as being above or north of the controller, those are called NBIs, or northbound interfaces. Now, what kind of language are we speaking between the applications and the controller? Well, it can vary. There are options. What we're going to focus on, one of the most popular options out there, is called REST APIs. If you want to jot this in your notes, REST is representational state transfer. This is an example of an NBI, a northbound interface. Think about going to a web server. If you go to a web server and you send a request to get content from that web server, or maybe you're putting in your credit card information and you're putting information on that web server, you're using a series of HTTP verbs to do that. That's what REST is doing. REST is using verbs that HTTP uses, like get and put and post. And we'll see lots of others today. But we're using HTTP verbs to send our intent down to that controller. Now, I say down to the controller, please hear me on this one as well. We don't have to have the controller in the mix. I could have it. In fact, what we're going to do today is we're going to have an application that talks directly to the router. The controller is going to make things a bit more scalable for us, but yeah, I could have my application send these REST APIs down to a router that understands those REST APIs. And when we send our instructions down inside of those, or using those HTTP verbs, the data that we're sending, and that data might say, this interface is up, here's its IP address, here's its subnet mask, here's its description, here we're setting up OSPF, here's the interface we want to advertise, here's the area. When we're sending that kind of information down, it needs to be formatted in a certain way. And with REST APIs, we're going to be using something called RESTconf for REST configuration. It can be formatted in one of two different ways. JSON, which stands for JavaScript Object Notation, or XML. That stands for Extensible Markup Language. We're going to be mainly focused on JSON today. And when we send that information down to a device, whether it's coming from our application, whether it's coming from Cisco DNA Center, it's coming from the controller, but when it goes down to that device, the way we can be vendor agnostic in all this is that different vendors have agreed to use the same data model. They can represent their configuration. Juniper, HP, Cisco, I'm trying to remember, no, Calpana, they were bought by Cisco, lots of others out there. But if they all agree to use the same way of modeling their data, I can send my intent to set this interface to this IP address with this subnet mask and this description. I can just put it in that model and it will apply to all these different routers with all these different operating systems because they all conform to the same model. Now, what do I mean by a model? Just to make it really simple, imagine the current iPhone 14 Pros that came out not long ago. Now, I've not upgraded. I've got the 13 Pro, and I'm perfectly happy with it. I'm probably not going to upgrade, but if you want to upgrade to the 14 Pro, we could create a data model to describe your ideal Apple iPhone 14 Pro. First of all, we have to understand that there are a couple of models. You could just get the Pro or the Pro Max, a larger form factor. We could say, what display size do you want? Is it 6.1 inches or 6.7 inches? You can choose your color. This year, they're coming in space black, silver, gold, or deep purple, which the deep purple looks really, really cool, by the way. I'm a big fan of that. And you could choose your capacity. How much storage, internal storage do you want? It starts at 128 gig, all the way up to a terabyte. I guess if you're taking maybe raw footage or something, raw video footage, maybe I don't need a terabyte, but you get to choose that. But you see, there are all these characteristics that could be used to describe the particular phone model that you want to purchase. So we could say, we're modeling this phone as a Pro Max with a 6.7 inch display. The color is space black, and the storage is 512 gigabytes. That's a metaphor for how we can model data, configuration data for our routers and switches. I mentioned that we could have all these different vendors agree to use a common data model. Are they going to say, let's use Cisco's data model? They're better than we are. No, there's an industry standards group called the IETF. And the IETF has, for example, a data model for interfaces that we would find inside of a router. And that's what I'm showing you here on screen. And this is called a Yang data model. A Yang data model. We see that the module name, if you can read that, it says it's IETF interfaces. And we've got a section of read-write information, things that we can change. And we've got another section. These sections are called containers. We've got a section of read-only information. So if I'm trying to retrieve statistics from a router interface, are you dropping packets? How or what's your bandwidth utilization right now? How many unicast versus multicast packets are you sending? That's read-only statistical information that I can pull from the router. But if I'm doing configuration, I'm going to be in that RW interfaces container. And notice under RW for read-write interfaces, there is sort of an indentation, and we have a list, it's called, and that's the configuration for a single interface. So maybe I've got a list for interface gig 0/1. Then I can have another list for interface gig 0/2 and 0/3. We can have, this is very modular. We can have repetitive lists with different information in them. And when I say RW interfaces star, we give the identifier for the interface, like gig 1 as an example. And then we have a parameter that we could either read or write. And here it says RW description. So I could read what the current description is. I could write a new description. And the kind of data that I'm going to be able to write is, in this case, is just a descriptive string. So that is called a leaf. That's one element that we can configure inside of that interface. Now, sometimes instead of having a type of string data, just where I'm typing out a description, this connects to the HQ second floor, we could have different types of data. For example, here for the when we're seeing when the configuration was last updated, we see that the type is actually another Yang data model. We're representing date and time using yet another Yang data model. Now, to make this a little bit more real world, let's take that same IETF interfaces data model and let's populate it a bit. Here we see basically the same thing. We see that we're using the IETF interfaces data model. We see that we have a container for interfaces. And within that container, we've got different interface nodes. We've got one for gigabit Ethernet 1. Under that, we've got an IP version 4 node. That's a chunk, sort of an indented chunk of configuration. And again, this is for Ethernet 1 or 0/1. We could have that repeating for other interfaces. So the Yang data model, do you get the importance of that? It's going to allow us to be very vendor agnostic as we're coming up with ways of pushing out our intent. It's going to make it so much easier. And one way of using that Yang data model is to use a utility called netconf. Now, this is very popular. And just to contrast it with the way we used to do things, we used to go in via the CLI, and we could do things like Telnet or Secure Shell, or even use SNMP to, yes, SNMP was originally designed to be able to configure our network devices. It still can. People just never used it for that very much. But mainly it was used to just monitor information. But now what we can do, instead of using those, I guess we could call them legacy approaches, instead we're going to use something called netconf, network configuration. And this is sort of like a client-server model, where we've got this back and forth communication going between maybe a program running on our machine or an SDN controller like Cisco DNA Center, where they're having this back and forth conversation. Now, here's the format. If you want to kind of jot this down on a piece of paper, the format of this, we're going to have that data, that Yang data model, that's going to be saying, give me your interface information, or here's how I want to set your interface information. That is Yang, and it's in that data model. Now with netconf, remember I said we had different different formatting options. I said with RESTconf we could have JSON or we could have XML. This is one of the reasons that I tend not to use netconf as much, because it's not as flexible. We must use XML. Personally, it's a personal preference. I like JSON better than XML, but I can hang with XML if I need to. But it's going to be formatting this Yang data in XML, and then this netconf packet is going to be going back and forth between our manager, whether it's our computer running a program or whether it's Cisco DNA Center. It's going to be going back and forth between the manager and the device being configured. And it's going to make updates based on that Yang data model. That's one way of doing it. Personal opinion here, my preferred way of doing it is to use RESTconf, because I'm already so familiar with the way web pages work. It literally uses the same protocol that I'm using to go buy a book from Amazon, or buy anything really now from Amazon. HTTPS. It's going to be a secure connection using HTTPS. It's still going to use that Yang data model, just like netconf did. And if we want to use XML formatting, more power to you. You can do that. But my personal preference is to use JSON formatting. I think it's easier to read. Maybe it's not for everybody. I like it the best. But we can use JSON formatting. And kind of a side-by-side comparison here, I think this also makes the case that HTTP verbs, they just look nicer than some of the netconf XML operations. Going way back, just to give you a history lesson, this is something, by the way, you should know for the CCNA exam. This is on the blueprint. They mentioned an acronym called CRUD, CRUD. And this goes back to the database days. The database people talked about ways of doing, of creating a record, of reading a record, of updating a record, or deleting a record. And the first letter spells out, not a very nice sounding word, spells out CRUD. And we have ways of using CRUD in RESTconf or NetConf. Now here, I said I would give you some more examples of those HTTP verbs like post and get. Oh, yeah, be careful with this one. If you're wanting to update something, you don't want to post because that's going to create it from scratch. It's going to override anything that's there. But if you just want to make an update to an interface, yeah, that's going to be a put or a patch, not a post. That's going to be a destructive write when you do a post. But those are some of the verbs that we might be using. All right, let's go ahead and start working with some of this stuff. In the real world, we're going to work with something called Postman. And here's the URL, and this is going to be in that document you can download at the end of class, but it's just simply postman.com. And you know what? I think I'm going to go out live right now. So let me take my face off the screen. So we'll be able to see this a little bit better. But let's go over to the DevNet website, and I've got the link for DevNet in that downloadable document as well. But the folks over at Cisco DevNet, they have given us an amazing collection of gear, and I think I mentioned this on Friday, but we can access that gear for free in different, as they call them, sandboxes. We can reserve time on some of those sandboxes. Some of those sandboxes are just always on. And I've already gone ahead and logged in here to save the time of actually it logged me out. It must have timed me out here. So let me really quickly, just so my login credentials don't show here, I'm going to relog myself in. 1 second while I do that. Okay, I am back in. So I'm logged in, and I'm going to go to the Sandbox catalog. I'll make the screen a little bit larger where you can see it. And there are plenty of technologies that we could practice here. Cloud security, data center, and on and on. I'm going to do a search for iOS XE on CSR recommended. See, oh, that's not XE. I said XS. That's better. Yeah, this is the one I was looking for. Notice it says it is always on, meaning we don't have to do a reservation. We don't have to set up a VPN connection to get to it. It's just always on. Now, please play nice. It is possible to be destructive and knock this out of commission until the folks at the DevNet Sandbox fix it. But here, we're given a publicly available CSR 1000V router. And it says if you want to communicate to it on using NetConf, here's the port for NetConf. There's the secure shell port. We're going to be using RESTconf, which you see is the HTTPS port of port 443. We're going to log in using a username of developer. We're going to use a password of Cisco 12345, capital C, and an I for the first, or a 1 for the first I. But what we're going to do is send a configuration instruction. Actually, for the public one, I'm not going to configure anything. I just want to retrieve some information. So the way we're going to do that is we're going to use a utility. I gave you the link for it a moment ago called Postman. And it's going to be able to send, using HTTP verbs, it's going to be able to send these APIs to the router to maybe get some information. So let me show you Postman. If you go to postman.com, you'll find yourself at this page, and I've already logged in. You can create an account for free, or you can log in, I think, using your Google credentials. But you can do everything from the web interface, as far as I've noticed. If you can see it down here, there's an option to download the desktop app. Let me make it larger where you can see that. I'm going to be using the desktop app. I just that's what I started out using, and I'm just a big fan of using the desktop app. So let me go over to that app right now. Okay, we're now sitting in this desktop app, and what we want to do is not start from scratch. We don't want to reinvent the wheel. Cisco DevNet gives us a lot of code that we can start with. So what I'm going to do, where it says search Postman, I'm going to search for Cisco DevNet. And under Cisco DevNet, the search results, there's a team that's called Cisco DevNet right there. I'm going to click on that, and it says the most active workspaces. The number one is Cisco's DevNet public workspace. I'm going to click on that. And look at all this stuff over here on the left-hand side. Talking about SD-WAN, yeah, we can start configuring things. It's going to give us the basic code to configure SD-WAN equipment. We're going to be dealing with the CSR 1000V running Cisco iOS XE. So let's see if I can find that. Yeah, let's open up Cisco iOS XE. I'm going to be using RESTconf, as we've been talking about. And I'm going to do something not destructive. I just want to get some information. How about we read a list of interfaces on a router? So I'm going to click Read IETF Interfaces, List of Interfaces. See, that's that reference again to the IETF data model. We want to get a list of interfaces on this router. So what we're going to do is we're going to send a GET request to that router in the sandbox. And it's going to say, all right, here are the interfaces. Here's the information about those interfaces. Now, here's the caveat. Please make a note of this if you're not already familiar with it. I'm currently in a workspace called Cisco's DevNet Public Workspace. I'm not allowed to run stuff from Cisco DevNet's workspace. I got to use my own workspace. So what I'm going to do is I'm going to take this URL. Notice the get verb. Here's some of the other verbs we could use. I'm going to use I'm going to copy this URL, and I'm going to go back to my own workspace. So I'm going to go to Workspaces, My Workspace. I'll open up a new tab, and I will paste in that link that says, give me a list of interfaces. And again, I'm doing this on a CSR 1000V, but this would work on a Juniper router that supported this IETF Yang data model. Now, I have to fill in the host information and the port information, you'll notice. We saw that on the DevNet Sandbox website. So let me go back to that. I'm going to copy paste the fully qualified domain name of that router that they're making available to us. And I'm going to replace host with that. The port, actually, I remember what that is. That's 443. So we'll say :443. Let's see. Anything else I need to do here? Yeah, I need to authenticate, don't I? I need to give it a username and password. So to do that, I'm going to go under authorization. And under the top of authorization, I'm just going to do the basic authorization. And it looks like I've already got it set up. The username is developer. The password is Cisco12345, capital C, and a 1 is the I. So this is looking pretty good. Let's try it. I'm going to say send this GET request to that router on port 443 with these credentials. And this is what's called a REST API call that says, give me your list of interfaces. And it comes back, and you can see the results down below. The first interface that goes out to the internet is Gigabit Ethernet 1. And because this is the one that allows us to get into the router, they have a very strongly worded description that says, management interface, don't touch me. I accidentally touched it once and I knocked it out for a while and they had to go reset it. So my apologies. I think the statute of limitations has run up on that. So I could admit that now. It was a long time ago. But please don't mess with that interface. But you can see its IP address. It's 10.10.20.48. gigabit Ethernet 2. Some people have gone in here and you can see things that other people have created. There's a loopback 5 interface, loopback 25 interface. Yeah, we could scroll through here. There's a lot of them, and we could see all of the interfaces that exist on that router. Now, by the way, what we're looking at right now is a Yang data model in this JSON format. What I could do is say raw. I could copy that and I could paste that in the body that I wanted to see. Now, I'm not going to do this. I don't want you to do this either, but I could say, I could go in there and change things. I could send just a chunk of this code, and instead of saying get, I could say that I wanted to post it. In other words, I wanted to update it. Now, please don't do that on their router. Just do that maybe on a local router, but that's how I could do it. What I want to do instead is I want to use a local router where we can actually make some configuration changes. So I'm going to open up another tab here, and I'm just going to use, let me get the same URL. I'll copy and paste that over here. And the router that I'm going to be using is a CSR 1000V that I've got running. I'm looking at the machine right now. It's right across the room. It's running in GNS3. And I promise to talk about that as another option of getting some hands-on experience. So here, this cloud connects this CSR 1000V router out to my local network that I'm on right now. And I can say that I want to open the console. Actually, I think I've already got the console open. Let me get logged in here. The username is Kevin. The password is Cisco. So there is my HQ CSR 1000V. Let's see what interfaces it has right now. I'm going to say show IP interface brief. And right now, this is the IP address that it has. So I'm going to copy that. And going back to Postman, I'm going to say that that is the IP address that I would like to communicate with. Now, I'm not done just yet. Because I started this in a new tab, I need to say what kind of data that I'm going to be using. Actually, I'm not going to be sending any. Before we send anything, I about got ahead of myself. Instead, let's do exactly what we did on the DevNet sandbox. Let's just pull some information down, and then we'll send some information. But let's start by making sure we can do exactly what we did before. So I'm going to go under authorization. I've got different username and password credentials for my local machine. I'm going to say I'm using basic authentication, but the username is Kevin, and the password is Cisco. I'm going to send that, and it comes back, and this is my local router. It says here's gigabit Ethernet 1. I don't have strongly worded descriptions there. I've got a gigabit Ethernet 2 and 3 and 4. Not a lot of interesting configuration going on here, but it still pulled it down. It pulled it down from my local router. Now let's actually make a configuration change using Postman. And in order to do that, I want to get some help from the Cisco DevNet workspace. So let's go back out to the Cisco DevNet workspace. Under workspace, use Cisco DevNet workspace. Let's see what we have here. How about this one? Add a new loopback interface. You see that? Let's do that. Let's say we want to add a new loopback interface. So what I'm going to do is I'm going to make sure that I'm looking at the raw data. I'm going to select it. I'm going to copy it. Then I'm going to go back to my local workspace. Let's create a new tab. And for the body, I'll say raw, and I'll paste that in there. Now again, I'm doing this on my local router, so I'm going to go back over and get this same information. It's going to be that same REST call, except this time, instead of using the get verb, I'm going to be using the post verb. And let's see, let's make sure our authorization is set up. Basic authorization. Okay, so Kevin and Cisco, that's going to be correct. Something else that I need to be concerned with is I need to say I'm sending this I'm using this particular format for the information I'm sending. So under headers, I'm going to go in here under headers, and I'm going to say application slash, actually, I need to, I almost gave the value first. That's not what I want. I'm going to say my content type is application slash Yang. I'm using a Yang data model, and it's going to be Yang data, so Yang dash data, and I'm using the JSON format, so I'll say plus JSON. And now we've updated the header. Let's go back and change the body a little bit, shall we? Instead of saying loopback 100, let's say we want to create loopback, to make it easy to recognize, we'll say loopback 123. And instead of saying configured by RESTconf, let's say configured by Kevin during Cyber Monday demo. And let's give it a different IP address. Let's say its IP address is 123.123.123.123. I'll leave the subnet mask as it is. I think we're good. Let's send it. It comes back and says created. That's encouraging. Let's go over to that router now. And you can see in the background it says, yeah, netconf by Kevin. So if I say show IP interface brief, look at that. Here is a brand new interface that we created. There it is. Loopback 123 with an IP address of 123.123.123.123. How about that, folks? Without even going into the CLI of that router, I was able to programmatically make a configuration change using Postman. Now, admittedly, what we did here was using utility where I had to type in, or I pasted in the that URL string. I had to say what our header type was. I had to give authentication credentials. We don't want to do that every time we have to program something. Instead, wouldn't it be better if I could actually have an application, like write a program, maybe a Python program that would do that for me? Yeah, that's what we're going to do here in just a few moments. And before I forget, I'm going to go ahead and reload this. I want us to start fresh with that program here in a few moments. But yeah, I think that was an overwhelming success. I hope you enjoyed that one, where we were able to use Postman to send a REST API call using Yang formatted data being sent with RESTful APIs, which used HTTP verbs to configure a router. That is a paradigm shift if I have ever seen one, compared to the way I have configured routers for just literally decades. So that's pretty exciting stuff. So if you were concerned about having to learn all this new stuff, hopefully that gives you a little peace of mind that it's not that bad. It's very learnable stuff. I said we want to write a Python program, and that's what most people, it doesn't have to be Python, but most people in network automation, they're using Python. to write these applications. I was reading a study the other day that showed the most in demand or the best programming language you can learn right now is Python. So I thought, you know what, let's do a sort of a basic Python tutorial today. If you don't have it installed on your machine already, or if you'd like to update the version on your machine, you can go to python.org. Like you see on screen, there's a download area where you can download the latest version. When I took this screenshot the other day, the current version was 3.11. I've got 3.10 installed on my machine. I installed it a little bit before I took that screenshot. The reason I make a point of this is some systems, like some older Mac operating systems, some Linux systems, they might come with a version of 2.7 installed. Probably you can use it, but most things are going to be working with some version of Python 3. And that's going to be our focus. Now, I've got it installed. So what I'm going to do is go out to a terminal, and if I look at my present working directory, I've created a little subdirectory called Python that we're going to be playing in today. And if I do an ls-l, I can see that, yeah, I've already got a Python program, and that's what I'm sharing with you in that download later today. And right now I've got a file called inventory.txt. If I say cat inventory.txt, just to show you what's in it, it's an inventory of some different Cisco gear that we're pretending I have in my inventory. But I just want to explain what those files are for. But once we've got Python installed, as I do, let me make this full screen so you can see it better. You don't need to see my face for this. That looks better. We got Python installed, and right now we can go into what is called the interactive interpreter, which means that Python does not have to be compiled and then run. It can interact with this and run real time. For example, what I can do, I could say Python. Now, again, if I have more than one version of Python, I can specify that version here. I have 3.10, so I could say Python 3.10, or since that's the only version of Python 3 I have installed, I can just say Python 3, and you see I'm at a different prompt here. If I can get my mouse to work right. Oh, you know what? My Mac laptop has decided to become another screen on my laptop. So now as I'm moving my mouse around, it's actually going on my Mac laptop. That's not helpful at all. But here we go. Let's see if I can highlight it for you. There we go. These 3 greater than signs, that's my Python prompt. And if I want to exit out of Python, I don't just say exit or quit. I have to give a function. I could say exit, open and close parentheses. Oh, if I could spell exit, open and close parentheses. Or if I go back in, another option is I could just do a Control D to get out of it. But let's get back in for a moment, and let's give some commands here from the interactive interpreter. The first thing that I'd like you to know about Python is, unlike me, it's really good at math, and it can do some things like this. It's going, let's say 5 times 5, where the multiplication sign is the asterisk, and it says, oh, it's 25. White space, by the way, does not matter. I can say 5 space times 5, excuse me, enter, and you, pardon me, and you can see that works. That works just fine. And one second here, I've got some stuff going on with my presentation console, just trying to get that sorted out. All right, I think I'm good now. Okay, now I'm good. What else can we do? Let's get out of this environment though, because even though we are in an interactive interpreter and we can give commands, there's a better environment. I'm going to say exit, open and close parentheses, and I'm going to go into what is called the interactive development environment. known as idle, IDLE for short. I'm going to say IDLE 3 because I'm running Python 3.10. And let me bring this up on another screen. Get to a blank screen. I'll drag it over. And this is my Python idle environment, my interactive development environment. And from here, again, we could do some math. We could say 5 times 5 is 25 and so on. But in addition to doing basic math, we can assign variables. We'll be doing a lot with variables. I'll say, for example, x equals 4. And then I could say something like x times 3. And it's going to know that x equals 4. So it's going to give me a result of 12. I can say 12 divided by 4. Notice that this is a little bit different. It gives me a 3.0. That's a different data type. We're going to be talking a lot about data types. This is a floating point data type. I could say 12 plus 4. No decimal there. That's just an integer data type. I could say 12 minus 4. Well, if I want to raise something to a power, I use 2 of the stars. I could say 4 star star 2. That's 4 squared. And that's going to be 16. Now, I've mainly just been working with integers that don't have decimal places, and that is one type of data that Python recognizes. If I want to see what kind of type of data I'm dealing with, I can use the function of type. And in parentheses, I'm going to say, what is the type of a 4? Well, that's an integer. What is the type of 4.5? That's a floating point. That's a floating point value. Oh, by the way, we can have strings. Like I could say, what is the type of, in quotes, my name, Kevin? You put strings in quotes, by the way. And it says the class is a string. Check this out. I could actually multiply strings. I could say, Kevin, close quote, times 4. And it says, Kevin, 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 Kevin. So that's kind of fun. Let's see how we could print something to the screen. I could say print. Get out of that. I'll say print, open parentheses, and I'll say in quotes, I'll do my name first of all, and I'll show you another way of doing it. Print Kevin Wallace, and it prints it. It sort of echoes that to the screen. Now, let's assign each of my names, first, last name, let's assign a space also to a variable. I could say, I've got a variable called first name equals Kevin. Now, notice the fact that I used an uppercase N in that variable name where it said first name. If you want to write this in your notes, that is sometimes called camel case. That's where if you're putting 2 words together in a variable, you don't capitalize the first letter of the first word, but you do capitalize the first letter of subsequent words. So here I'm combining the words first and name. I don't capitalize the F in first, but I do capitalize the N in name. You don't have to do it that way. It's just a very common way of naming your variables. Let's create another variable called space, and I'm going to say that it equals, in quotes, just a single space. Let's create another variable called last name equals, in quotes, Wallace. Try that again. Last name equals, in quotes, Wallace. Now, let's see if I can group all those together. This is called concatenation, where I'm adding multiple things together. I can say print, and then in parentheses, print whatever value is stored in the variable of first name, plus, in other words, add on to that output, whatever's stored in the value of space, which is just a space, and add on to that output, whatever value is stored in the variable of last name. And let's enter that. And it prints my name, Kevin Wallace. Excuse me. Another data type we have is a Boolean data type. Is something true or false? Is it greater than or equal to, for example? I can say type true. The word true itself is a Boolean variable, so is false. I could say Does the first name equal Kevin? Here's how I would do that. I would say first name, and I don't just say equal Kevin because that would actually set the variable. But if I want to check and say and ask the question, does the first name equal Kevin? I could say equal equal. We give two equal signs, and then in quotes, say Kevin. It says true. Yes, it does. What if I said, does the first name equals Wallace? It should not equal Wallace, so no, that's going to be a false. However, what if I said first name, does it not equal Wallace? To say not equal, it's an exclamation point, or some people call that a bang. It's a bang equal sign. Does that equal Wallace? Let's see. Oh, I misspelled first. That's embarrassing. Let's try that again. First name, exclamation point equals Wallace. It says true because that's a true statement. The first name does not equal Wallace because it equals Kevin. We could do this with integers. I could say is 5 less than or equal to 4? Nope, it's not. Is 3 less than 3? No. But is 3 less than or equal to 3? Yes, it is. So that's just a look at playing with some different data types that we have. We've got strings, we've got integers, we've got floating point variables. Let's take a look at some more programming stuff here. Let's look at something called a conditional. In other words, a conditional says, if something is true, then do this. If it's not true, then do something else. So I'm going to say if, pardon me, if 10 is less than 100, and I'm going to give a colon here to let me go down to the next line. That's going to let me have a compound instruction. I'm going to say if 10 is less than or equal to 100, then I want to print 10 is less than 100. Let's see, I did something wrong there. Oh, yeah, I forgot my second quote. Let me try that again. If if 10 is less than 100, print 10 is less than 100, and I'll press enter again. And that was a true statement, so it says, yep, 10 is less than 100. Now, what we've been doing right now, I said, this is great because unlike some programming languages that I used to work with, like C or C++, where you had to write a program, then you had to compile it, and then you could run it. Here, we've just been sitting at the interactive interpreter, and as soon as we enter something, it does it. It makes things go a lot quicker. But what we can do instead is actually write a program that makes it reusable. We don't have to type it in every time. So here in the idle environment, I'm going to go up to File, and I'm going to say New File, and I'm going to save it. And I'll just save it as cybermonday.py for Python. And let's do another example where we're using some of those true-false conditions. I said that I do a lot in the collaboration space. And one thing we talk about in collaboration with IP phones is the concept of a native VLAN and a data VLAN. Actually, a native VLAN and a voice VLAN, we often say. So I'm going to say my native VLAN equals 1. That's going to carry my data from an attached PC going into a phone. I'm going to say that my voice VLAN equals 100. And I'll say if the native VLAN equals the voice VLAN, colon, Then I want to print the native and voice VLANs are the same. What if they're not the same? I can say else. So what do I do if that's not the case? I'll say instead print the native and voice VLANs are different. Let's save this now and run it. No need to compile it. I just say save. And then under run, I say run module. And when I do that, here on my idle screen, it says the native and voice VLANs are different. Well, that was kind of cool. Now let's go back to our file for a second, make some changes. Here, let me just delete what we have here. Let's do some quality of service stuff. Let's say that the COS, the class of service, will say equals 5. A DSCP value for a packet equals 46, which is what we would expect with voice packets, by the way. And I'll say if COS equals 5, and so this is a compound conditional. I'm saying both the COS has to equal 5 and the DSCP has to equal 46. If COS equals 5 and DSCP equals 46, colon, then I want to print this is a voice packet, because that is a characteristic of a voice packet. If that's not the case, I'll say else. I want to print this is not a voice packet. Let's save and run that. I'll say save, run module, and it says this is a voice packet. It met those anticipated criteria. Now, let's spend some more time in the interactive interpreter, and I want to show you a few other things. Let's go back to our we're actually in the interactive interpreter. Let's just stay here for a moment. Let's take a look at another type of variable we could have. You might want to make a note of this. It's called a list variable, or a list data type, I guess would be a better way of saying that. A list, for your notes, that is an ordered list of comma-separated values enclosed in straight brackets. I'll say that again. A list is an ordered, so they're not just random. I might say, give me the 5th item in the list because that's significant. A list is an ordered list of comma-separated values enclosed in straight brackets. Let me, instead of typing everything out by hand and just consuming class time, I'm just going to paste in. Let's paste in a list, but notice the syntax here. It says inventory, that is my list, and then in straight brackets I have some things in my inventory. A Catalyst 3750, notice it's in quotes because it's a string, comma, another item enclosed in quotes, comma, another item enclosed in quotes, comma, another item enclosed in quotes, and when I'm done, I close out my straight brackets. So I just assigned a list data type. And if I want to see what type of data the variable inventory is, I could say type inventory, and it says, oh yeah, that is a list. We could also say how many items are in that list. I could say len for length. What is the length of inventory? 4. Oh, something else. I could use length for lots of things. I could say, what is the length of the string Kevin? There are 5 letters in Kevin, so it says the length is 5. If I want to see all the items in the inventory, I could simply say inventory. There they are. Or, remember we said that it was an ordered list. I said that order was significant here. Here's how we can go in and cherry pick specific items from that list. I could say and here's a huge point. Please hear me on this. A huge point is the numbering starts at 0. Please write that one down. The numbering starts at 0. So I'm going to say inventory and then in brackets, I'll say 0. And this is saying, show me the first item in the list. Catalyst 3750. If I want to see the second item in the list, I would say inventory, in brackets, 1. Again, because the numbering starts at 0. If I want to see the very last item in the list, I could say inventory, and instead of having to count over and see how many are in the list, I can just say inventory -1. And that's going to give me the very last item in the list, which is a 7945G IP phone. If I want to see the next to the last item, I can say inventory, and in brackets, -2. That's a 2911 router. So it's an ordered list. And I can go in and, again, cherry pick things from that list. And I could say, what is the length? I think I may have already shown you this, but I want to make sure you get it. The length of inventory, it's 4. There are 4 items in the inventory. Now, there is a similar but very different data type for your notes. So, again, a list, it's an ordered list, separated by commas, enclosed in straight brackets. There's another data type for your notes called a dictionary. A dictionary is an unordered list of name-value pairs. For example, there could be a variable name of last name, and the value might be Wallace. There might be another name of first name, and the value might be Kevin. So we've got these pairs of data, a name and a value. The name and the value are separated with a colon. If you want to have another name-value pair, there's a comma in between those pairs. And the big difference is, instead of being in straight brackets, a dictionary is in curly brackets. Let me show you. Again, to save typing time, I'll just paste it in. But there it is. I'm saying IP address. And here is my first name-value pair. The name is router A. It's a string, so it's in quotes. And I'm saying colon, that separates the name and the value. And the value, in quotes, is 10.10.10.1. So I've got a name of my device, router A, and it's got a value, which looks to be the IP address of 10.10.10.1. And then I've got a comma and another name value pair. Router B, it's got an IP address of 10.10.20.1. Switch A, 10.10.30.1. Switch B, 10.10.40.1. Notice they're in curly brackets. And if I were to, and I assigned all that to the variable called IP address. And if I say type, oh, didn't mean to use a curly bracket there. If I say type, it says that is a dictionary. If I say IP address, and then I name one of the, remember we had those name value pairs. If I want to see what the value is for a name, I can specify the name. One of the names in quotes was router A, RTR-A. I'll put that in brackets, and it says, oh, that's 10.10.10.1. So that's a way of querying what we have. What if I want to add something to the dictionary? Here's how I do that. I would say IP address, the dictionary name, IP address, and then in brackets I would say what my new name is, RTRC. Let's have router C now. And I'll say that it equals the value of 10.10.50.1. And if I say IP address now, you're going to see that it has a new entry. This was not here before. We just added a name value pair for router C. If I want to see if router C is in my list, I could say RTR-C. And I could say, is that in the variable of IP address? True. So that's a little Boolean check for us. Next, let's take a look at how we can do looping. Here's what I mean by that. We can repeatedly go through a section of code until a certain condition is no longer met. For example, I've already got a variable called inventory. if I just say inventory, that's what's in inventory right now. What if I wanted to pull out the word, what if I wanted to pull out the inventory items that contain the word catalyst? Check this out. You're going to love this. I'm going to say for item, so this is a for while loop, it's called. So for item in inventory, colon, if the word catalyst is in item, and I'm going to explain all these as soon as I get it typed in, then I want to print whatever the item is. And notice it came back and it printed those two items that had catalyst in the name. Now let's break this down. I'm saying for item in inventory. What that means is I'm going to start off with the very first item in this inventory, which is a Catalyst 3750, and I'm going to assign that to the variable called item. This is my first time through this loop. The next line says if the word catalyst is in that item, then print it. Well, here, Catalyst 3750, yeah, the word catalyst is in that, so it printed it. Catalyst 2960, the word catalyst is in that, so we printed that. But for the other two, the router and the phone, yeah, it didn't have the word catalyst, so we did not print those. That is a for while loop. That's not the only kind of loops we can have, but I wanted to give you an example of one of them anyway. Now, let's go back to our editor. Let's write some programs as we start to bring our little Python tutorial to a close. Here is a program that I'm just going to paste in just to save time, and then we'll talk about it. Paste it in. Here, I'm setting the value of inventory, kind of like we did before. Here's what's in my inventory, and I'm going to say the current inventory is, and then we're going to print it. Pretty simple. Let's save. Let's run it. And it says the current inventory is, and it lists everything out. Now, let's check out a new command that is going to be able to prompt the user for some input. What if the user wants to add an item to the inventory? Let's go back. And we'll say item equals. Now, here's the new command I'm introducing you to. This is a way for us to ask the user to enter data. I'm saying item equal input. So that's the keyword, input. Item is the variable. We could call that anything. But I'm saying I want the user to input something, and they're going to be prompted with the string enter new inventory item colon space close quote close parentheses. And in order to add something to the variable of item, I'm going to say inventory dot append whatever the value is that the user had typed in. And I'll say print the current inventory is, and we'll print it out. We'll say print inventory. In fact, you know what? Let me paste back what we had to start with. So it's going to initially set the inventory. It's going to show us the current inventory. Then it's going to prompt us to enter something new. So let's save this. Let's run it. And it says the current inventory is that. And it says, let's add something. So I'm going to add a 7945G. Actually, we've already got one of those. 65G IP phone. And it says, okay, the current inventory is, and it shows the now expanded inventory. So we were able to query the user for some input and add that information. Now, we might not want to add that initial data like the inventory into the program. It's probably a lot more convenient if we just have that stored in a file somewhere. It's going to be a lot easier to update that. Because remember, at the very beginning of this, I showed you that I had a file called inventory.txt. What if I did this? What if I pulled information in from that file? So let's go back here, delete all that, and I'm just going to paste in this little program, and we're going to talk about it. File open. So I'm opening a file that's in my current directory that's called inventory.txt. I showed you the contents of that earlier, and I'm opening it with the R flag. R means read, as opposed to W, which means write, as opposed to A, which means append. I'm just reading from this. It's not destructive. And I'm saying for item in file. So it's looking at the very first item in that inventory. And it says, well, this is just getting rid of an extra carriage return. So this is just sort of a cosmetic thing there. We're stripping off the /n that would be there otherwise. And we want to print that item. And then we're going to close that file. Let's save this and run it. And see what it did? It went out to that file in my file system, inventory.txt. And it read in one item at a time, and it printed one item at a time. Nice. Let's see. What should we... yeah, let's do one other thing. Let's read in the inventory items from the file and use those to populate a variable instead of just printing them out. So here's what we can do. I'm gonna create a variable that's called inventory. So here's a list variable, and it's just called inventory, and there's nothing in there. It's open bracket, close bracket. But then I'm opening this file on the hard drive called inventory.txt. I'm just reading it, and we're reading through each of those items, and I'm saying inventory.append, whatever the value of that item is. So I'm starting with an empty list, and I'm populating it, and then when I'm done, I'm going to print it. Let's save and run it. And there we see the output. Okay, let's do, that was going to make that my last one. I want to show you one other thing, though. We haven't actually written anything to a file. I want to show you how to do that. Let's see how to write a file, and I don't want to be destructive and overwrite my inventory text file. I just want to add something to it. So instead of using the write mode, I'm going to use the append mode. I'll paste that in. So I'm opening that file, inventory.txt. I'm appending it. I'm not overwriting it. And I'm saying while true, while there is an item that I can read. It says the variable of new item is going to be whatever the user says it is. So we're saying enter the new item. And if they give the keyword of exit, that means, okay, I'm done adding items. And it will say all done, and it will break out. If we're not entering exit, it's going to write that new item and put a carriage return after it. Or it's going to write that to the file. So let's save and run that. And it says, what is your new inventory item? And I'll say, let's say it's a Cisco 7945G IP phone. Let's say that let's say my next item is a Cisco Unity Express module. Let's say my next item, well, let's say I'm done. I'll just say exit. Let's go. It says all done, and it exits us all the way out. Now, if I were to go back to my terminal, if I were to, let me open up another tab here. If I were to look at the contents of inventory.txt, you see that it has added those two items that I was just prompted for. So that, my friends, is a look at that is your crash course on Python. I don't want to leave you with just that, though. Let me give you some book recommendations. One book recommendation that I have for you, and this is I would recommend you start with this one. It's called Learn Python in One Day and Learn It Well. It is a very thin book, and this is a very digestible book. I went cover to cover through this book. It teaches you the basics. It covers the kind of stuff we did today and even a little bit more. But this is a great first step in learning Python. Again, learn Python in one day and learn it well. Another recommendation I have for you, and this is, I use this more as a reference. It's not something I've read cover to cover, but if I want to figure out how to do a particular function or a particular routine, I might turn to this. And it's called Python Crash Course by Eric Matthews. So there it is. I'll give you a look at that. Python Crash Course by Eric Matthews. So those are a couple of recommendations for your next steps in learning Python. Hey, welcome back from the break, everybody. I wanted to show you one more thing that I neglected to do before we went to the break. We went through our primer on Python, but I wanted to kind of tie it all together. The connective tissue of the first part of class and the second part of class. How can we now take a Python program and go make a configuration change? So let's do that really quickly, and then we'll wrap things up with cybersecurity. We're still on track to be done 3 hours today, so not much more to go. I mentioned that we probably would not create a lot of programs from scratch. We would start using our own code and just update that, or we might go out to GitHub and get somebody's code. I'm including a link in the download you'll get to if you stick around to the end today. I'm including a link to this GitHub location, and I don't know who this person is, but they have some great code on here that shows how to deliver a JSON formatted payload to a device. You see this area right here that says payload? This is being used to add a loopback interface. Kind of like we did with Postman. So we can take that code, run it against our CSR 1000V, and create a loopback interface. So what you can do is you can say, give me the raw format of that. You can copy it, and you can paste it into a text editor and update it for your own needs. Now, notice a couple of things here. It says import requests, import JSON. If you run into some of these programs, some of these scripts out on GitHub, and it's importing different Python libraries, I wanted to show you how you would install those. So let me go to a terminal really quickly. Let's say that I did not have the Python package called requests. So I would say pip for package installer for Python. I'm running version 3.10, and I would say install requests if I didn't have that. Now, for me, it says, yeah, this requirement is already satisfied. I've already got it installed, but you would use pip. Again, pip stands for the package installer for Python, and that's how you would get those. Now, back to our code for a second. Here, they have hard-coded the domain name of the server, of the router we're trying to configure. They're giving the credentials here. They're giving the port number here. And then they're taking those variables that they're assigning as part of the code, and they're putting those variables in this URL. And they're setting the loopback to a loopback 10,000. There's a lot of stuff, in other words, that's hard-coded in here. I thought, wouldn't it be great if we could kind of update that based on what we just learned about Python programming? What if we updated that to where we would be prompted to enter that information? Oh, I still have my face on screen. Let me get my face off the screen so you can see this a little bit better. And what I want to show you right now is what I've included for you in your download today. And it is, if I can find it, here it is. Here is my modification to that program on GitHub. Notice that I'm using a series of these input functions. Remember, we saw that before the break. I would say, for example, I have a variable name called uname for the username. And I'm saying input, and then I'm asking, hey, what's the router username? And I'm prompting for the password, and I'm prompting for what port number we're using. I'm prompting for all that information that might be different. So you can go through that at your leisure, but let's run it. What do you say? And let's see if we can make an update to our CSR 1000V. Before, just like in a magic show, let me show you. I've got nothing up my sleeves right now. Let's take a look and see what interfaces we have now. I'll do a show IP interface brief. And right now, I've just got those 4 gig interfaces. I got rid of the one we created earlier. I've got those 4 gig interfaces. Let's create a loopback interface, shall we? So let me go back to our... Let's go back to my terminal window. My Python directory. There we are. If I do an ls-l, here's that program that I've updated that I'm going to use. It's called addloopback.py. And here's how we run it. I'm simply going to say Python 3.10 because that's the version I have installed. And I'm going to say run add loopback.py. And now it's going to interview me and ask these questions instead of just having to go in and hard code it in the program itself. So what is the IP address of the router? Well, in my case, it is 172.16.106.226. In fact, you know what? Let me make sure that's really true. Because I did reboot it, I want to make sure it still has the same one. Yeah, it sure does. So that is the IP address of the router. The username is Kevin. The password is Cisco. The port is 443. Let's create loopback interface 22. And I'll give a comment. I'll say added by Kevin during Cyber Monday demo. And it says, what's the IP address of that loopback interface? Let's make it 22.22.22.22. We'll give it a 24-bit subnet mask, 255.255.255.0. And it's off. We'll give it a few seconds. And it says, successfully added the interface. Let's confirm that. Let's say show IP interface brief. And look at that. There's a brand new loopback interface. If I do a show run, let's see if we can see our comment that we put in there. Yeah, added by Kevin during Cyber Monday demo. So I know we've covered a lot with network programmability, so let's just sum up really quickly here. We started out by learning the benefits of SDN, software-defined networking. We learned some of the terms that were used to describe a software-defined network, southbound interfaces, northbound interfaces, REST APIs. We talked about netconf and restconf and Yang data models. We saw that a Yang data model specifically could be used to more generically represent the configuration of a device, which in our case was a router. And using that data model, we saw how we could pull configuration information from and send information to a device using HTTP verbs. That was an approach called REST, representational state transfer. We saw how we could use a utility like Postman to send a payload in JSON format to that device. But we wanted to be able to do that using a program. So we spent some time learning the basics of Python. We saw how to install Python, how to use the interactive interpreter we saw how to use idle, which was sort of a better version of the interactive interpreter. We saw different data types. We talked about integer, floating point, Boolean, list, dictionary. We saw conditionals. We saw how to do looping. We saw how to get user input, how to search a list, how to print to the screen, how to write a program instead of using the interactive interpreter, how to read from and write to external files. Then we combined our knowledge of REST and Python to modify a Python script that we got from GitHub to prompt us for that information about a router interface, and we ran it. And we were able to, just by answering some simple questions through a program, add an interface to a CSR 1000V router. My friends, we just did network automation.